Okay, hi. Who all are there? Aditya, Samuel, Amog, Siddhant. Hello. Hello.
Hello.
Hello, Aditya. Hi.
Hello.
Hi,
Yeah, hi.
Kondanya. Hi, Ramcharan. Who all are there from Kormangla? Siddhant, Amog. Are you there?
Hello.
Okay, yeah. Just text me on that the text bar that you have so that I can see the attendance who all are there. Okay, just text some message like hi hello you can say over there for attendance purpose. Okay, and tell me last class, this is on YouTube live. Okay, so we are all live now. Okay, so last class, what have we discussed in chemical kinetics? Let them join. Let others to join. Okay, until then we'll just see what all things we have discussed last class. We'll see some questions till then. Okay, and then we'll move on. Okay. So tell me what all things we have discussed last class. What is the last part that we have discussed? Ramcharan.
So we were doing a rate of the reaction,
Okay.
law of mass action.
Law of mass action we have done. Okay.
We were doing new rate law. That was the
Okay,
class.
okay. New rate law we have done. Okay, we were doing new rate law. New rate law we have done the expression. No elementary, non-elementary reaction we have discussed already. Yeah.
So no, I don't think so. So that one we didn't.
Okay. Concentration under concentration we are discussing all
So
this.
wait, so elementary is the rate of
One
reaction
step.
is K into A to the
Yeah, yeah.
power
One.
the
Yeah, yeah.
concentration
One.
of A to the power A.
Yeah,
So
one step. One step
yeah, we did
reaction.
that.
Okay. And Aditya, you tell me.
Uh, yes, sir. We were done till we made those graphs, reaction lifetime.
Graphs for first order, zero order.
Yes, sir. The first order reactions, all
Okay.
concentration, product time, and
Okay. Okay.
completion of reaction time. Those ones.
Okay, okay. So we'll do a quick revision of this. Okay, order things we have to discuss. Let all core Mangala guys to join. Okay, till then we'll discuss. We'll do a quick revision on this. Okay. So Ramcharan and Kondanya, we have discussed the rate expression. Okay, the law of mass action and all. Okay. Have we discussed the rate of the unit of K rate constant?
No.
No. Okay. So you see the rate law expression that we have already done for a suppose for a given reaction. For a given reaction, you see
So are you sharing screen?
it's not there.
No.
Just a second. Okay. So yeah. So now it's there. I think. Yeah. Yeah. Is it visible?
Yes, sir. So
Okay.
it's
Okay. Fine. So I have given you this thing in the last class that suppose any reaction if I write A plus B gives any product. Okay. So we do not know about this reaction anything whether it is elementary or non-elementary reaction. So for this we have given a new rate law, and according to that the rate expression R is equals to K concentration of A to the power any term X and concentration of B to the power Y. This is what we have done in new rate law. Yes or no? Hello.
Hello, yes, sir.
Okay. So what is this Ramcharan Kondanya? We have done till here only, right?
Yeah.
Okay. So what is this x and y? What is this x and y? X and y are the
Experimentally
experimentally
determined.
determined quantity. Okay. So the next thing you write down, x and y are the experimentally determined quantity. If I write the order of reaction with respect to A, that is what the power of A term in this. This is what we call it. This is a rate law expression we have. Okay, RLE. Okay, this is what? This is rate law expression RL E. Okay, so whatever the power of A we have in rate law expression, that is nothing but the order of reaction with respect to A, that is X. Okay, now order of reaction with respect to B is again Y. Okay, this is the order of reaction with respect to one individual species. If I ask you the overall order of the reaction, overall order, that will be what? That is denoted by N, and that will be the sum of X plus Y. The sum of the power of the reactant species or the species which involves in rate law expression or that. Okay. So just power of the sum of the power gives you the order of the reaction. Okay. This order, this order of the reaction, and this one is like very important. The order of reaction can have any value. Okay. So this N or order can be negative, okay, can be positive, can be zero, and can be any fractional value. Anything possible we have. Okay, and this order is what? Order is a experimental determined quantity. Experimentally determined quantity. Okay. We define the order of any reaction with respect to various experiment. Okay, that's why we are calling it as experimentally determined quantity. Theoretically, we cannot say. By looking at the reaction, we cannot say the order of the reaction is whether 0, 1, 2, or whatever it is. Okay, so this thing is very important: negative, positive, 0, or fractional. Okay, so now this k is what? K is the rate constant. Okay, k is the rate constant. Okay, so if I write down one side order and this side the unit of k, unit of k. Okay, so this order can be 0, 1, 2, 3, any fraction, suppose half, anything possible, right? So when the order is 0, what is the unit of k we have to find out? Order is 1, what is the unit of k? Okay, so if you see, if I have to find out the unit of this k, okay, so what we can write, this expression, the unit of rate is what? It is mole per liter second. Okay, or if I write down mole per liter into time, this is the unit of rate, is equals to k. And what is this a and b? What is this a and b? It is the concentration, right? Okay, so concentration we can write what? Mole per liter to the power x, and b is also concentration, which is nothing but mole per liter to the power y. Okay, so if you solve this, you'll get the unit of k would be, it is mole per liter to the power x plus y divided by this. So we can write down mole per liter to the power 1 minus n into time inverse. Tell me, did you get this? Ramcharan Kondanya?
Yes, sir.
Yeah, where
So, but
what?
how can it be negative? The order.
See, there are like two, three things into this. Negative, the order of reaction is negative. It means then the mechanism of the reaction is very complex. Okay, we have various reactions. See, two things I'll tell you in this. Okay, first of all, the negative overall order when it is negative, the mechanism of the reaction is very complex. And how it is negative or positive or zero or fractional, that we cannot say. Like I said, it is an experimental quantity. Okay, we define this as experimentally. Understood? So on the basis of experiment only we can say this. And how it is negative or positive or zero or fractional? Correct. So with the on the base of experiment, we are calling it as. Now, as far as our syllabus is concerned for JE, you will not get any reaction which overall order is negative, but maybe order with respect to particular species may be negative. Okay, yeah. How it is negative or positive, that is experimental quantity, we cannot tell anything on this. Okay, we'll see some questions in that. We'll see the order with respect to one particular species is negative. I'll give you some examples now only. Okay, just give me 2-3 more minutes. Okay, like you say, first let me finish this unit part of it. Okay, so unit of K is mole per liter to the power 1 minus n time inverse, right? Hello, right? where
Yes.
where n is what? N is the order of the reaction. Now you see the important thing over here, it is what, on the basis of n, whether it is 0, 1, 2, or whatever value it is, the unit of K will change, right or not? Yeah.
Yes,
So
sir.
basically we cannot, say that the unit of K is this particular term always. Okay, on the basis of order, the unit of K will change. So if I ask you, when the order is 0, the unit of K is what? It is mole per liter time inverse, right? When order is 2, when order is 0, what we can write? It is again only time inverse. When order is 2, what it is? Mole per liter to the power minus 1 time inverse, right? And we also call it as, or we also call it as mole per liter inverse is liter per mole time inverse. Like this you can write down for second order, for third order also, and for um, half order also, right? Copy down this. Okay, Aditya,
Yes, sir.
I think we have done this, right?
Yes, sir. We have done this.
Okay, yeah, just give me some more minutes, I'll just finish it off. Okay, so like this, on the basis of order, we can find out the unit of K, right? Now the important point here, it is what, sometimes in the question they won't mention the order of the reaction. Okay, order of the reaction they won't mention, but unit of K, if it is given, the value of unit if it is given, and then on the basis of these units you can easily say whether the order is 0 or 1 or 2 or whatever it is. Did you get my point, Ramcharan, Kondanya?
Yes, sir.
Okay, so our unit of K is very important. Okay, we'll see some question onto this. Now you see, like you said, when the order is negative, suppose if I write down this example, and that is what, 2O3. One example you write down, 2O3, it gives 3O2, conversion of ozone into oxygen. Okay, this rate law, if you write, R is equals to K concentration of O3 square and concentration of O2 minus 1. This is the rate law we have of this. Okay. So with respect to
Minus 3.
how it is minus 3,
This.
no. That's what I said. This, see, you just listen to me carefully. Okay, this is very important. You don't uh, like do like this. Okay, this expression is experimental. Okay, if the reaction is given, okay, then you cannot write down this expression. This information I am giving you, it is not that we are drawing this or writing down this information, this rate law expression, on the basis of this reaction. Okay, I can give you some more example in which this rate law expression has nothing to do with the reaction given here. Okay, so first point you have to keep in mind is what this rate law is experimental. All these par here we have 2 and -1 are the experimental value. It has nothing to do with this stoichiometric coefficient. Okay, but if suppose if I tell you that this reaction is simple reaction, if I give you this information, okay, that this reaction is simple reaction, then the rate expression you can write, and that will be what KO3 2 and O2 -1. Then you can write O2 3 when it is elementary reaction. But since the reaction is not elementary, so and if it is not mentioned in the question that this is an elementary reaction, then you cannot write down the rate law expression. Correct? This rate law expression I'm giving you. Okay. So you see, with respect to O2, the order is -1, negative order we have. With respect to O3, the order is what? 2. Overall order, if I ask you, what is the overall order? That will be 2 plus minus 1 is equals to 1. This is the overall order of the reaction. Did you understand this?
Yes, sir.
Okay. Sometimes, for JE, for solving this JE question, whatever the portion we have in JE, we write the overall order like this only. Okay, 2 plus -1 is equals to this. But if you read out some higher standard book, okay, like some graduation or post graduation book, in that they have written, whenever you have one order with respect to one species, the order is negative, then overall order we cannot write down like this. Say what the order is undefined, okay, in that case, but it is not in our syllabus now. So whenever you get this rate law expression, whether whatever the power we have here, whether negative or positive, you simply add those power and you'll get the overall order of the reaction. Correct? Understood?
Yes, sir.
Okay, so now you see, if I write down the rate of reaction decreases with time, okay, so the concentration decreases. Okay, rate constant that you have here, 2 points just you write down here. Rate constant depends, means K. Okay, rate constant or K depends only on this point. You write down K depends on temperature, catalyst, and activation energy. We'll discuss this later on also. Just this one point you write down. Okay, activation energy. Okay, activation energy. Aditya, have we finished zero order reaction?
Sir, I
Aditya,
think he got disconnected.
who are there?
Only you, me, and Kavit. I think. Yeah.
Mm, okay, anyways, chalo. So you write down the definition of order. Definition of order you write down. It is represented by N. Okay, write down. It is a sum of power. It is a sum of power. It is a sum of power of all concentration term. It is sum of power of all concentration term appearing in rate law expression. Concentration term appearing in rate law expression. Yeah. Hello.
Hello. Yes, sir. Sorry, I lost.
Yeah. Okay. Just give me like 5-10 minutes. Okay, then we'll start next thing. Okay. So you see, Ramcharan and Kontanya, we have this A plus B plus C. Suppose one reaction I write down gives product P. Okay. So if I write down the like rate law expression for this, that will be what R is equals to any constant, that is rate constant K, concentration of A to the power X, concentration of B to the power Y, and concentration of C to the power Z. Okay, all these X, Y, Z are what? Experimental quantity. Again, I am telling you, experimental quantity. Okay, this is very important. That's why I'm repeating this again and again. Experimental quantity. And if I ask you the order of the reaction with respect to A, the answer is what? X. Order of reaction with respect to B, the answer is what? Y. And similarly for Z also. Overall order, if I write down overall order, that will be N, and it is equals to N is equals to X plus Y plus Z. This is the overall order we have, which can be 0, positive, negative, anything. Okay. Yeah. Okay. So now you see, depending on the order of reaction, we have various growth kinetics. Okay, like the reaction that you have. But before going into that zero order reaction and all, okay, first we'll see the various examples in this. Okay, which is again important. Okay, few reactions I'm going to give you. Okay, those reactions and rate law expressions are important. Okay, you have to keep these reactions into mind. Okay, so write down various examples of this. Okay, so examples of various reaction you write down. First one, 2N2O5, 2N2O5 gives 4NO2 plus O2. Okay, its rate law expression is R is equals to K N2O5, concentration of N2O5 to the power 1. Okay, and this rate law expression is what? It is experimentally determined expression. Okay, 5 Br minus plus BrO3 minus. This reaction probably it is given in exercise center module also. Okay, 6H plus, and it gives 3Br2, 3Br2 plus 3H2O. This rate law expression for this one is what? It is K concentration of Br to the power minus 1, concentration of BrO3 minus to the power minus 1, and concentration of H plus to the power 1. Third one, you see, 2O3 gives 3O2. This we have done just now, and its rate law expression is K concentration of O3 to concentration of O2 minus 1. Fourth one, N2NO2 plus CO gives NO plus CO2. Okay, its rate law expression is R is equals to K concentration of NO2 square concentration of CO, right? Concentration of CO to the part 0 we have here. Hello, hello. CH3CHO gives CH4 plus CO. Its rate law expression is R K CH3 CH3 CHO to the power 3 by 2. Okay, and the last one in this is this one, 2SO2 plus O2 gives the catalyst we are using here is NO, and it forms 2SO3. The rate law expression for this R is equals to K concentration of O2 R1 and concentration of NO 2. Okay, this NO is a catalyst here, you see. So the point here is what? NO is a catalyst. So all these expression, few are important in this. Like the first one is important. Okay, this you must keep in mind. This one is important. Okay, and the last one is also important. Okay, these two three are important. Okay, so you must keep in mind. Now why I have given you all these examples, because you see in the rate law expression, first of all, these rate law expression or what it is, these are the experimental number. Okay, experimental expression actually it is. Okay, so these experimental expression we can not write down by looking at the reaction itself. Okay, all these expression, and the important thing here it is what, that in this expression you see we have product also, right? This is the product here, O2. We have product also, and we can have any catalyst also into this. See, okay. So it is not necessary that in rate law expression we always have only reactant. We can have product also, we can have catalyst also. Okay, that is what one note you write down here. In rate law expression, in rate law expression, we can also have product and catalyst. We can also have product and catalyst along with reactant. Next point. Next point. There is no relation. There is no relation with stoichiometry and order of the reaction. There is no relation with stoichiometry and order of reaction. Last point, and this one is important, the third one. The reaction intermediate will never appear in the rate law expression. The reaction intermediate will never appear in the rate law expression. In the rate law expression. Okay, some examples also I'll give you later on in this chapter only. Okay, now the unit of rate you have done. Have you written the definition of rate constant, Ramcharan Kondanya? Definition of rate constant? Yeah.
The base is it's the rate of reaction when concentration is unity.
This you have done, no? Okay. Now coming back to this, only one small thing we have. Okay. See, we are talking about concentration. Okay, concentration. No, we are talking about order of the reaction. Okay. So on the basis of order of the reaction, we can have different reactions possible again. Okay, and that is nothing but we are calling it as kinetics of various order of reaction. Okay, or growth kinetics. Okay. Write down the heading now. kinetics of various order reaction. Okay, so now in the first like order in this we are going to discuss is the zero order reaction. Zero order reaction. Okay, so what are zero order reaction? You write down the definition of it. These are the reaction these are the reaction in which reactions in which the rate is independent of concentration term. Okay, reactions reaction goes with a constant rate. Okay, a constant rate. Okay, see, like I said, when we were discussing this concentration term, see, if you see, we are discussing this, the factors affecting the rate of the reaction. In that, the first thing we have discussed is the nature of reactant, right? And then we are discussing concentration, and all these things comes under concentration term only. Okay, and if you remember, there I have told you that rate of uh, reaction is like is rate of reaction and concentration of reactant are related to each other in a very complex manner. Okay, and why it is complex? Because you see, um, the concentration and rate, the relation of concentration and rate depends on the order of reaction. Okay, so like I have taken the first reaction, that is zero order. Here the rate of the reaction is independent of concentration. Why it is independent of concentration, that also you can understand. You see, if I write down, and this is like simple also and important. Okay, this is the same thing we are going to use in the coming, no, in the coming different orders, like first order and second order. So these are the two important points you have to keep in mind. Some examples of zero order reaction, you write down 2 3 examples you should keep in mind for JE point of view. Like any photochemical reaction. Okay, any photochemical reactions are zero order reaction. Okay, so photochemical reaction means what? The reaction which depends on the intensity of light. Okay, photochemical reaction which takes place uh, in presence of sunlight. Suppose H2 plus Cl2 in presence of sunlight, H nu, gives 2 HCl. Okay, these reactions are what? These reactions are independent of concentration of H2 and Cl2, but it depends on the intensity of light that we are using here. That's why it is a zero order reaction. Okay, this is a photochemical reaction, the first one. The second one, we have dissociation of gas on solid surface. Okay, dissociation of gas on solid surface at high pressure. At high pressure. Okay, like you see, dissociation of NH3 molybdenum gives N2 plus 3H2. This is also an example of zero order reaction. Okay, enzyme catalyzed reaction are also zero order reaction. All these are zero order reaction. Okay, now coming back to this derivation point of it. Okay, you see, suppose if I assume one reaction, and that reaction is what? A gives product. Okay. And what I assume that at T is equals to 0, the concentration of A is A naught, and this is 0, there is no product. At T is equals to T, X amount of this dissociate and gives product. So we'll write A naught. What is left? A naught minus X. And this gives you X here. Right. This A naught minus X is nothing but the concentration at time T. That also we can write it as AT. So what do you understand by AT? Hello? 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 Yeah. So AT is what? AT is the concentration of reactant at time T. Right?
Yes, sir.
Concentration of reactant at time T. So now you see, if I write down the rate of it, rate is equals to what? Minus D concentration of A by dt, right? Rate of reaction is this only, Aditya, uh, Aditya, and this Ramcharan, right?
Yes, sir.
Kondanya, correct? And this we can also write what? The rate constant into concentration of A, and since we know that this reaction is zero order reaction, so we can write here what? A to the power 0. Ramcharan, fine.
Yes, sir.
So what we can write further, now we have to use some basic mathematics, integration and all, and we can solve this expression. dA by dt is equals to what? K, which is a constant. You see, that's why the reaction goes with a constant rate. There is no concentration term, and hence the rate is constant in this. Now simply we use integration into it. So minus of d concentration of A is equals to K dt, correct? And in this, the time is going from 0 to T. Okay, and concentration at time T is equals to 0. What is the concentration we have? A naught. At time T is equals to T, what is the concentration we have? AT, which is nothing but A naught minus X. Correct. So when you solve this, what you will get? Left hand side we have A naught minus AT is equals to KT. Okay, A naught minus AT is equals to KT. So the concentration at time T, finally, the expression that we get here is concentration at time T is equals to the initial concentration minus K into T. This is what the expression we got for zero order. Yes or no?
Yes, sir.
Okay. So this,
So you said rate constant is not dependent on the stoichiometric ratios, right?
rate, rate of
Yeah.
rate of individual species. Rate constant depends on temperature, catalyst, and all these things. Okay.
Doesn't depend on even the stoichiometric.
No, rate constant has nothing to do with stoichiometry. It has only temperature.
No, because the rate of reaction is by minus 1 by the coefficient the into the constant into change in concentration.
Correct.
So then that means it will be
No, actually, with change in stoichiometric coefficient, in the same proportion, the reactant is also reacting. No, if you take 2A over there, then it becomes A naught minus 2X. Correct. So that half and this 2 in the numerator cancel over there. Have you done one question of N2 and H2 gives NH3? Last class? I've given you that question. Ramcharan,
yes, sir.
the same logic we can apply here also. Correct. Now you see, what is the T half? This means what? This means what? This expression is important. Okay, zero order and first order is very important for JE point of view. Okay, this means what? It is a concentration at time T. This is the initial concentration K and T, right? Means after time t, when the reaction takes place, the concentration becomes 80. That is the meaning. Now, if I ask you, what is the, you have written this, no? Can I rub it off? Yeah.
Yes, sir.
Yes, sir.
Okay. So now you see, if I ask you, what is the half life for this reaction? So if I write down, if I calculate this half life, what is half life? It is the time required for 50% completion of the reaction. For 50% completion of reaction. Okay. We represent this half life as T half or T 50%, like this also we write. Okay. So when time T is equals to T half, right, what is the concentration A naught? AT is equals to what? What should we write? Half of the reaction takes place and A naught is the initial concentration. So what is the concentration left? A naught by 2. Is it correct? So this two value you can substitute in the above relation that we have just got. A equals to A naught by 2 is equals to A naught minus K, and what is T over here? T is T half. And this gives you K T half is equals to what we can write? A naught by 2, right? So T half is equals to what? A naught by 2K. This is the expression of half life we have in this. Yes.
So
Yes, sir.
why do we have to find half life?
Sometimes you have this question at what is the half life of this reaction? That's why we are calculating this T half life. It's just a formula. Okay. If you do not calculate also, and if you get question over there, you just substitute half of the concentration after time T. That is nothing but T half over there. Understood? Why specifically we are calculating T half? Because they ask this question of T half sometimes. Okay. And this, you see, the important point here we can conclude is this: T half is directly proportional to what? A naught. A naught is the initial concentration. Right. This is important. So if two reactions are there with different initial concentration, then half life for more initial concentration will be more. Simply it takes more time to complete half of that reaction. Yes or no?
Yes, sir.
Okay, so just we'll see two or three graphs into it. Okay, and after that we'll go to the first order reaction. After finishing first order reactions, we'll see various questions, because solving is important into this. Okay, this is completely mathematical chapter. A little bit of theory, then some formula, integration, differentiation, and then question on that. Okay, so we have to solve the question into this. Okay, so first graph you see into this, two three graphs we have. Okay, the first graph we are going to draw is for the concentration of reactant and time. Concentration of reactant and time. Second graph we have rate of the reaction. This is the rate of the reaction and concentration. Third graph we have T half and A naught. And A naught. Okay. Next one we have concentration of product and time. It is the concentration of product and time. Okay, so all these graph you have to understand. Okay, in book all these graphs are not given. Okay, one more graph you can write down, that is degree of dissociation. Degree of dissociation and time. Degree of dissociation and concentration, I guess it is concentration. So you see, the first thing is what? Concentration of reactant and time. What is the to draw the graph? You should know what? You should know the relation of concentration of reactant and time. And what is that relation? We know AT is equals to A naught minus KT, right? So we have to draw this and this, concentration and time. So what will be the graph? The graph will be a straight line like this with negative slope, correct? So slope of this graph is what? Minus k, y is equals to mx plus c. Okay, this is the nature of graph we have. We can find out these 2 points also, this point and this point, by putting at0 and t0 at 2 different points, correct? Rate and concentration, is it a constant graph? Because rate is independent of concentration. Yes,
Yes, sir.
right? And what is the relation of t half and a naught? T half is equals to a naught by 2k. So this relation is what? It is y is equals to mx type of graph we have, so it passes through origin like this. And slope of this line is what? 1 by 2k. Concentration of product. Concentration of product increases with time. Okay, because concentration of product is what? It is x. If you remember the reaction, A gives product, it is A naught 0, A naught minus x, and this is x. So with time, this x is increasing because the reaction is going into forward direction, right? So we can write what? X equals to kt, we have the relation. You see, at is equals to what? A naught minus x. That is what we have now. If you compare these two, this relation and this relation, so instead of x, what we have? Kt. So we can write what? X is equals to kt. X is the concentration of product. So this graph will be what? This graph will be again a straight line passing through origin like this, and this represents the concentration of product X is equals to kt. You see, initially the product concentration is 0, and as the reaction proceeds, the concentration of product is increasing. What is degree of dissociation? Alpha. It is the number of moles reacted, and that is what we have, X divided by initial number of moles, A naught. Okay, so X and A naught relation is what? You see, X and A naught at constant. Oh, sorry, we have alpha. No, alpha and A naught relation is what? At a particular point, alpha and A naught is also this. It is this. No, is it clear?
Yes, sir.
Yes,
Okay,
sir.
so these are the 5 graphs we have. Okay, that you have to keep in mind. Correct. Aditya, have we finished one thing, that AP progression and all?
No, sir.
We
We
haven't
still
done
tight here.
till till here. No, huh? Okay. So we have 2-3 points that is left in this zero order reaction, which is again very important for JE point of view. Okay, it helps you in solving the questions into it. Okay, so you see the next point. See what we can write here. See, and these 2 points, write down the note here. Okay, must remember these 2 points, very very important. Okay, not for board point of view, but obviously for uh, JE point of view. First point is what? Write down the concentration of reactant react in equal time interval. The concentration of of reactant react in equal time interval follow the pattern of arithmetic progression AP. This is very important. Who all are there from Kormangla? Aditya, Amog.
Yes, so I am there. Among and Naman are on YouTube.
Okay. Okay. So ask. Amog is saying that we have done arithmetic progression. Okay. Okay. Anyways. So give me just 1-2 more minutes. We'll finish this. Where is Siddhant? Siddhant is not there, right? Okay. Now you see, Ramcharan,
Yes, sir.
tell me this. Suppose at time t is equals to 0, what is the concentration we take initially? A naught. Correct? At time t is equals to 0, t, what is the concentration we have here then? 80, right?
Yes, sir.
And that will be equals to A naught minus KT. This is what we have derived just now, right? At t is equals
Yes,
to,
sir.
at t is equals to 2t, what should we write here? A naught minus 2 KT. Instead of t, we have 2t. At t is equals to 3t, what is the concentration we have? A naught minus 3 K T, and so on we can proceed. Correct? Correct, no?
Yes, sir.
So what is the AP? It is a common difference, right? Okay.
Yes.
AP is what? The difference must be common in the consecutive term, right? So you see, what is the difference we have here between T and 2T? What is the difference we have? In these two terms, the difference is what? KT. This one is this, or this one is this is KT only. Similarly, what is the difference we have here in these two terms? Again, we have KT. And in these two terms, the difference is what? KT. Right? So you see, after equal time interval 0 to t, t to 2t, 2t to 3t, the time interval is equal t and t only, right? So in equal time interval, the reactant or the product or the concentration of the reactant that we have here and here, it follows what pattern? Arithmetic progression. Okay. Yeah. Now the application of this is what? Suppose if I give you one example on this we are doing. Okay, A naught is suppose 100 molar. Okay, and 80 is suppose 90 molar we have. And for this, the time required is what? Time required is 10 seconds. Okay, correct. Now the question is, what is the concentration of reactant at t is equals to 30 seconds? What is the concentration at t is equal? So you have to find out AT is equals to 30 seconds. What is the concentration we have? Can you do this? Aditya, tell me. Amog, tell me the uh, answer of this. Amog is saying 70 molar. How did you do, Amog?
also have an analytic side.
How did you do, Ramcharan?
So using the AP thing.
Yeah, correct. Huh? Using the AP thing, right? Now the point here is what? See, you can do this by AP thing, right? Directly, you don't have to even put your pen on the paper. Also, you'll get the answer. Okay. Now the another method also you can use for this. You see what? We have this relation of AT is equals to A naught minus KT. Correct. Now you see what all things are given in this. AT, you know, for the first set of data, AT is given 90. A naught is also given 100 molar. Correct. T is also given, right? So you can find out K from this, the first data that you have, right? And then this K you can substitute for the another set of data. Okay. So what you have to find the concentration of reactant time T is equal to. So for the second set of data, we have to find out this AT, and A naught is given, A naught is 100. K you can find out from this. Okay. That K you substitute here, and T is given 30. We can do like this also. Yes, Aditya,
So I did that.
you did this one.
Yes.
Aditya, how did you do this question?
Yeah, so same this way also.
This way only. See, the point is this method you can use for your board exam. This kind of question they can ask in board exam also. Okay. So first you find out K from this, substitute K over here, you find out AT. Right. This you can do in board exam. But for JE, you have to save your time. Okay. And that is what the application of this AP thing that I told you comes into the picture. Okay. What I told you, since the reaction that is given, the reaction is of zero order, it is mentioned, right? For a zero order reaction, all these things are given. I am not giving you the whole literature of the question. Okay. I'm just giving you the data and information. Okay. This is the same thing you'll get in literature form in the exam. Okay. So since I know in AP, the concentration at equal time interval will be what? It follows AP, right?
Yes, sir.
Okay. So what we can write, if from 100 to 90, what is the time required for this? It is given 10 second, right? So in another 10 second, what is the concentration we get here? Here, it will be 80 only because the common difference must be same. And in another 10 second, what will get next? 70. So you see 10 plus 10, 20 plus 10, 30. After 30 second, the concentration is what? The concentration is 70 only. Is it clear? Yes. Naman? Naman, understood? Right? No? So you don't have to calculate by this if you are writing down JE test or JE exam. Okay. But if you do like this in the board exam, you will get only 1 mark, that too for correct answer only. Okay. So write down each and everything, solve properly, find out K, and then use this into this in your board exam. But don't use this method for JE exam, it will kill your time. Okay, use this method. Now the thing another important thing here, it is what, from this example only you can understand that at a given time equal amount is reacting, right? You see, in first 10 second 10 molar is reacting, in again another 10 second 10 molar is reacting, in again another 10 second 10 molar is reacting. Correct. So write down equal amount of reactant. The next second point, both are important. Okay, equal amount of reactant reacts, equal amount of reactant reacts in the same time interval. Correct. Yeah.
Yes, sir.
Okay. Now the application of this is what? Suppose I'll just give you one example. Okay. Similar example I can give you. Suppose if I tell you, if I give you this data that a reaction is going for zero order reaction and it takes 10 seconds to decrease the concentration from 100 molar to 90 molar. It is 10 seconds it takes. Okay. Then what is the time it takes to convert 50 molar to 40 molar? What is the time required here? T is equals to what? So since what I said that equal in the given time interval, equal amount will react. Okay, so 10 to 90 if it goes, what is the amount that reacts? It is 10 molar. Okay, so for any interval, if 10 molar is reacting, the time taken for this process will be 10 seconds only. Did you get this?
Yes, sir.
Whatever the interval it is, whether it is 30 to 20, whether it is 35 to 25, whether it is 45 to 35, where it is 79 to 69, whatever interval you take, if 10 molar is reacting, then the time taken in this process will be what? 10 second only. Did you understand this?
Yes, sir.
Okay, so basically this kind of application saves your time in the exam. For this, you see, again, if you find out k from this data, okay, and for this it will be easy because 50 40 is given. Sometimes they'll give you very weird data like this. Suppose 47 to 37 they'll give you like this. So this kind of data is very difficult to solve, right? Addition, multiplication, subtraction, and all things you have to do. 50 40 is still, it is quite easy to solve with this kind of data. But when they will give you this kind of data, and if you calculate k from here, substitute this here and find out t, you will get the correct answer into this also, but it takes a lot of time. Okay, so one thing just to keep in mind, that whenever you have equal amount is reacting, and for that the time will be same whatever the interval it is. Okay, so these are the two very important application of all this thing you have that you must keep in mind. Understood this? Yeah.
Yes.
Okay, now we'll see some questions onto this, but first we'll finish first order reaction also, because in zero order you will not have much questions. Based on these application you may have some questions, but we'll see first order reaction first, and then we'll see some question. Do you have all, do all of you have center module with you right now?
Yes, sir.
Yeah. Chalo, we'll see first. First we'll see first order kinetics, and then we'll see some questions. Okay, you can get your module. No, you're at home only, all of you, right? Okay. Now you see first order kinetics we are looking at. First order reaction. Okay. See, first order reaction, like I said, that this reaction are those in which the rate depends on the concentration term. Okay. So basically, write down in this type of reaction, in this type of reaction, the rate is determined by the rate is determined by change of one concentration term only. Okay, now as I said that like zero order few reactions are there that you have to memorize, that these reactions follow zero order kinetics. Similarly in first order there are a few examples, few reactions we have which follows first order kinetics. Okay, so for zero order and first order, these reactions you must memorize. Okay, because sometimes in the question they won't mention you the order of the reaction. Okay, so now the first reaction in this, all those reactions which involves radioactivity. Okay, so the problem related to radioactivity. Okay, all these are first order kinetics. Okay, secondly, write down growth and decay of bacteria. Growth and decay of bacteria. This is also first order kinetics. Okay, third one we have, that is inversion of cane sugar. We have done this in organic also, right? Inversion of cane sugar. What is inversion? See, we have sucrose, that is C12H22O11, and when you do the acidic hydrolysis of it, H2OH plus, it converts into what? C6H12O6, right? Sorry, C6H12O6 plus C6H12O6, right? This we have, it is glucose, and the next one is what? Fructose. And what is this? This is sucrose. What is inversion of cane sugar? Cane sugar is sucrose only. What is inversion of cane sugar? If the behavior of compounds changes towards the PPL, plain polarized light, that is inversion, correct? If one compound is rotating the plane polarized light in clockwise manner, after reaction the product that we get rotates the plane polarized light in anti-clockwise, then what we say? We say inversion takes place. Understood? So you see here, this sucrose is dextro rotatory in nature. It is dextro. Okay. Glucose is also dextro. Okay, glucose is also dextrorotatory. Fructose is what? Fructose is levorotatory in this. Levorotatory. Okay, but the amount of fructose is more in this reaction. Okay, more fructose form into this. That's why this sample behaves as what? Levorotatory in this case. Okay, and hence it is, we call it as what? Inversion takes place, because dextro to levo the conversion takes place, and that is nothing but the inversion we have. And this inversion, if you remember, we call it as what inversion? What? Yeah. Who is this? Amog. Yeah. Okay. So this is Walden inversion, right? Correct? No. Okay. Now you see, these are the three important example we have. The next one also, you see the next example in this. The fourth one we have, and that is that decomposition of H2O2. Okay, or also we can write acidic hydrolysis. Write down first acidic hydrolysis of ester. Hydrolysis of ester. When you heat disonium chloride, okay, C6H5 and 2Cl. When you heat disonium chloride, benzene disonium chloride, then it forms alkyl aryl halide, that is C6H5Cl plus N2 gas releases. This is also first order kinetics. Okay, so I'm giving you all possible type of no reaction in this, because this first order and zero order is very important for JE point of view. Okay, so I'm not leaving anything into it. H2O2, decomposition of H2O2 gives you H2O plus half of O2. This is also first order kinetics. And the last in this is a decomposition of NH4 NO2, and it gives you N2 plus H2O. N2 plus 2H2O. Okay. All these reactions follows first order kinetics. So at least this 5-6 reaction you must keep in mind, important. Okay. Okay. Now coming back to this derivation part of it, like we have derived for zero order reaction. Oh, just give me a second. Okay. So we are going to derive now this expression for first order kinetics. Okay. So you see, again we are going to assume one reaction here, and the method is same, exactly same that we have done. Just you have to tell me one thing, and when I ask you, you tell me that, and that is what the important point we have. After that, you can do everything. We can assume the reaction like this, first order reaction, correct? Now you tell me what is the rate expression of this. Rate is equals to what we can write? K times concentration of A, and power of this concentration term is what? 1, because the order is 1. And this is equals to what we can write again in differential term? Minus of dA by dt. Correct, Ramcharan Kondanya?
Yes, sir.
So we can write. So if you are able to write this expression, after this you have not to do anything into it. Now what we can write, you see, and one more thing, let me write down. Forgot to write down here. At t is equals to 0, see, at t is equals to 0, for this, before this rate expression, you write down this. At t is equals to 0, the concentration of A is A naught and product is 0. At time t is equals to t, the concentration of A naught is what? A naught minus x, and this is what? X. And this is nothing but what we have? It is a concentration at time nothing but AT, right? AT is equals to A naught minus x, basically. All these terms, how do we write? That you must know. Okay, because you never know what kind of reaction you are going to have here. Suppose 2A, if they give over here, then you have to write down A naught minus 2x. Accordingly, according to the stoichiometry, we have to write down this expression. So this expression you have to be very comfortable while writing down all these things. Okay. So now you see, with this expression, what can I write down this minus of d concentration of A by concentration of A is equals to k dt, right? Yes. Now we can integrate this 0 to t. At 0 time, what is the concentration we have? A naught, because we are talking about reactant, right? You must keep in mind this is reactant only. Okay. And at time t is equals to t, what is the concentration we have here? A t or A naught minus x, whatever you want, you can write. Can you integrate this and tell me the expression? Tell me.
Log mod A naught by A naught minus x equals to KT.
Ha. So we'll get this. Ramcharan Aditya Kondania.
Yes, I got it.
Did you get this? K is equals to 1 by t ln A naught by A naught minus x. Or we can also write it as 1 by t A naught by AT. You must keep one thing in mind, that this term A naught minus x, it is the concentration left of reactant. It is not the concentration that is reacted. It is the concentration left. Okay, suppose 100 to 90 if you are going, then this A naught minus X is what? It is not 10, it is 90. X is 10. Correct? So this is very small thing, but I have seen that the students gets confused over here. Okay, that's why I'm repeating this thing. Okay, this is the concentration left. And one more thing, if you convert this ln into log, then it gets what? 2.303 here in the numerator. Correct? So this is the expression we have for first order kinetics. Okay, like we have got in zero order. Okay, so now you see one more important thing, the rate of the reaction here. The rate of the reaction is this only, minus dA by dt, right? And the rate of the reaction depends on the concentration term, right? And with time, we also know the concentration of A is decreasing, right? So rate is also with time decreasing. Yes. So when the rate is decreasing, so you will have the time when the concentration of A is very small, and at that point of time, the reaction rate is very less. Correct. That's why I say that. That's why we say the reaction lifetime is what? It is the time required for 98% of the completion. Because when the 98% of the reactant is completed, then the rate becomes very less, and we assume that the reaction is not taking place. Okay, we cannot assume the further reaction for that. Okay, so this is the reaction lifetime. It is the time required for 98% of the completion. Okay, which is again not true for zero order reaction, because zero order reaction is the only reaction which goes towards the 100% completion. Can I say this also? Because there what happens, the rate is independent of concentration, right? So this question they have asked once in NEET exam. Okay, which of these reactions goes towards the 100% completion? Okay, so we cannot have any reaction whose rate depends on its concentration term. Is it clear? Because as concentration decreases, rate also decreases, and when rate decreases, then 100% completion is not possible. Okay, we cannot wait for that long. Okay, so zero order reaction are the only reaction which goes towards the 100% completion. Clear, Ramcharan, Pandanya?
Yes.
Okay, so just one point I'll write down here, rate as concentration, and concentration of reactant. Concentration means what? Concentration of reactant. As concentration of reactant decreases, rate of the reaction also decreases. Okay, this is very important one point we have. Okay, now can you tell me what is half life for this reaction?
49%.
Not 49. See, for half life, see it's not like 9. For this
Okay,
for this
we,
for this kind of reaction, our 98% is only 100%. This is what very precisely if you say. Okay, our 98% is 100%. So half life is always time required to finish half of the reaction, means 50%. Okay, why I have discussed this 98% here, because when I say the time reaction lifetime is what, whenever somebody asks you what is the reaction lifetime, obviously you will say what, the time required to finish the reaction, 100% completion. But since the rate depends on concentration term here, so this kind of reaction never goes to the 100% completion. And what we assume at 98% only, we assume that the reaction is finished. Since the reaction is very slow, that we cannot wait for that long for the 100% of completion, and we assume that okay, chalo, 98% is there, so this is it, the reaction is finished. Okay, that is the reason. But whenever we say half life, it is always 50%. Okay, t half or t 50%. Can you tell me the expression of it? Can you find out? Tell me. What are you doing?
So we just change the limits of integration to 0 to d half and a naught to a. It is the a naught by 2.
Correct, correct. So basically, whenever you are calculating, see, again and again, I am telling you, in this chapter, it is not chemistry, it is simply mathematics. Okay. You have to simply apply the mathematics with few concepts. That is it. Nothing you have to memorize into it. Okay. So you see, when what it means, when T is T half, then what should be the concentration? AT is what? AT is the concentration at any point of time T. When T is equals to T half, so AT is equals to what we can write? A naught by 2. Right? These two values you substitute in this expression. Correct? You'll get what? K is equals to. So you don't have to do this integration term always. Integration thing always. Yeah, so we'll write what K is equals to 1 by T half ln AT A naught, we have A naught, and AT is what? A naught by 2. Can I write down this? A naught gets cancelled, and T half is equals to what we get? ln 2 value is what? 0.693 by K. Right? So you see, in zero order reaction, T half is directly proportional to initial concentration. Here, T half is independent of initial concentration. Of initial initial concentration of what? Reactant. Okay, this is again important thing we have. Okay, all these informations are important. Okay, copy down this, then we'll see some graph. I hope all of you have center module. You can have it, right?
Yes, yes.
Okay, so first we'll see some graph. One more facts we'll see into this, and then from the module we'll see some questions on this. Okay, zero order and first order. Done. Ramcharan, Kondanya finished.
Yes, sir.
Kondanya. Okay. Okay. Write down. Okay. One more thing we are going to see here. You see, from this expression, what we can write, A naught by AT is equals to e to the power KT.
Yeah.
Yeah. So the concentration at time T, that will be what? A naught e to the power minus KT. So when you draw the graph, you'll have the exponential relation of this concentration and time. Yes or no?
Yes.
Correct. So this is also one important relation we have copied on this. AT is equals to A naught e to the power minus KT. Okay. Now, in this only, we'll discuss one more thing. So if I write down at T is equals to 0, the concentration is A naught. At T is equals to T, the concentration is, what is the concentration?
A naught minus.
No. It is, no. It is first order. So it is A naught e to the power minus KT. Just now we have done, no?
Yeah.
AT is equals to A naught e to the power minus KT. Correct? See, you can stop me wherever if you are not getting anything. Okay, because there is nothing to memorize in all this. 2t if you substitute instead of t, we'll write 2t. Correct? A naught e to the power minus k minus 2 kt.
So it's a geometric progression.
Geometric progression, yeah, correct. So it is 3t a naught e to the power a naught e to the power minus 3 kt. Now you see, in the first example or zero order, we got this relation of this thing is what? This concentration term is what? Or in AP there in zero order. So if you find out the ratio of this by this, it is common ratio is what? Common ratio is e to the power, sorry, e to the power kt. This by this is
So, but don't we take
anything you take, you'll get other. Taking this by this, e to the power kt, this by this, you'll get e to the power minus kt. But if you are doing final minus initial, here also you'll do final minus initial. You'll get the same thing. Correct? So this by this is kt, this by this is what? Again e to the power kt. The common ratio is same in all these concentration at equal time interval. Again, you see the time interval is equal. Correct? Time interval is equal. T and T only, right? So it means what? At equal time interval, the concentration of the reactant follows what progression? Geometric progression. This you write down. At equal time interval, the concentration of the reactant follows geometric progression. Correct? One more important thing, conclusion we can draw in this reaction, that whatever initial concentration you are taking, A naught is 100 molar, A naught 200 molar, and whatever initial concentration you are taking, if temperature is same, or in the indirect way, if K is same, rate constant, then what happens? T half won't change. Because we know T half is what? It is independent of initial concentration, correct?
yes.
T half, the value is 0.693 by. So all these facts you must keep in mind. They may give you the all the data they'll give you, and they'll ask you to find out T half, but you don't have to find out because T half is independent of initial concentration. Okay. One thing also we can conclude: T half is inversely proportional to K, right? So that K and T relation we'll see later on in Arrhenius equation. Okay, so we are not discussing onto that. But when we discuss Arrhenius equation, with increase in temperature, what effect, what effect takes place, or what happens on this value of K, rate constant. On the basis of that, we can write down the relation of T half also. Later on, we'll see that. Okay, so we have gone one step ahead into it. But again, whatever is the initial concentration, if K is not changing, means if rate constant is not changing, T half will be same for all kind of reaction. Okay. So one more thing can conclude: if the initial concentration is more, right, here and here, and T half is same for both reactions, so which one is going with a faster rate?
The second one.
The second one. Yes, Ramcharan. Ramcharan, Kondania. Did you understand this? See, here the initial concentration is 100 molar, correct? And for T half, 100 must convert into 50. Means the reaction is 50 molar is only reacting. But here, 200 to 100 molar. Here, what is reacting? 100 molar is reacting. But for the reaction of this 100 molar and 50 molar, the time required is what? T half only, which is same for both the reaction, correct? So obviously, this reaction has to go with a faster rate. Am I clear with it? Okay. So I'm just giving you this data, okay, because the rate T half also depends on K. So this we can say only if K is constant. Correct. Only if K is constant. And what is the relation of K? How K may change, rate constant may change. That we'll discuss later on also. Okay. This also you keep in mind. Okay. So these two things are very, very important, AP and GP things and this thing. Now, one very much important point we have here, the last like conclusion in this, then we'll see the graph. That is, I'll give you one in a question form. Okay, so that will give you better understanding of this concept. Okay, so suppose if I have a question, right? I'm giving you in the data form, right? Only data I'm giving you. A naught is suppose 80 molar, right? And 80 is 72 molar, right? K is and T is given for this, and that is 10 seconds. Suppose. Okay. Then the time required for 80 to be means final concentration to be final concentration to be uh, oh, I'll write down like this. Wait, what is the concentration? 80. What is the concentration? 80 you have to find out after suppose 30 seconds. This is the question. Did you understand my question? Initial set of data is this: A naught, 80, 80, 72, and for this change, time required is 10 seconds. So what is the concentration we have after 30 seconds? Tell me this. Answer.
So calculation is a bit tedious. Fractional.
Fractional you are getting now. Okay. So and that is what, and that's why you know everything, but you won't do this question in the exam. Okay. So the thing here you have to understand that what we have discussed in zero order, that equal amount will react, right? But that was in zero order. Here what we say that equal percent. We'll come to this question a bit later. Okay. Suppose I'll give you now one information. Okay, and that information is what? That for a given period of time, equal percentage of reactant reacts. Now what is the meaning of this? Okay, suppose from 100 to 90 if it is going, right? So what is the percentage react over here? 10%. And whatever time it is, let's say it is t, right? So it means what? From 90 to after this again, if you have to react further 10% of the reaction, so for this also the time required is t only. And what is the reactant left over here? 81, not 80, because 90 10% of 90 is 9. So 90 minus 9 is 81. Again, suppose further you have to go 10% of the reaction, you have to do it again. For this also the time required is what? T only. And what is the 10% of it? 8.1. So 81 minus 8.1 is what? 72.9. Correct, no? So like this it goes. So there what I have told you, that equal amount reacts. Here we have equal percentage reacts. Correct? So now if this logic you apply over here, so what you can say, 80 to 72 it is going. So what percentage react in this? 10%, right? So 80 to 72, 10%. So further 10% reaction, what is the time required? Here if it is 10 seconds. So in 10 seconds, further 10 seconds, that is total it is 70 seconds, sorry 20 seconds. So 10% of this will react, and 10% of 72 will be what? 7.2. 7.2. So 72 minus 7.2 is, it is 64.8. Calculation you just check. Okay, I don't know. I'm doing it verbally. Okay. Now further 10% if you have to react, we also required what? 10-second time. 10%. So 10% of this is 6.48. And when you do the calculation, you will get 54.3 something you'll get. 57. 57 or 58? 58, I guess. 6.42, 58.32 molar, correct? So the point here is what? If you use the log value and all, okay, AT is equals to 1 by T, sorry, K is equals to, by method if you go, what you'll write? K is equals to 1 by T ln A naught by AT. This is what you do. Substitute all the value, find out K first, and again this K you use to find out this AT concentration here, right? Which is very, right, very calculative. And log value, if you do not know, if it is not given, then you cannot do this question. Okay, but actually if you go by this method, you don't require any log value and you don't require any calculation. Understood my point? Okay, so here what happens, you have to keep this in mind, that in zero order equal amount reacts and here equal percentage react. Okay, so we can cross verify this also. First you write down this point, for a given period of time, for a given period of time, equal percentage of the reactant reacts. Okay, understood? So these 2 points you must remember. Now we'll see graph of it, then we'll see some question on this. Okay, the first graph we have log of concentration or ln of concentration versus time. It is a log of concentration. AL, right? Concentration of reactant. Okay, log of concentration of reactant is square bracket you write down here. And here we have time. Okay, then we have again concentration of reactant, concentration of reactant and time. What is this voice? Some train or something? Rate and time. Rate and concentration. What is the nature of all this graph? Tell me.
Most of it like e to the power minus extra.
Why you are taking e? I have given you log, so base is 10 over there.
So
That's why I've changed that. Okay,
that
if
usually comes from
Ramcharan, tell me
Not too sure.
why. You see, log and time. Okay, what is the relation of this? Can log a and t, right? So can I write this? Kt is equals to. I'll just change the color here. For first graph we are discussing. Okay. So you see, can I write down? See, whenever you have to draw the structure and graph, no, whatever axis we have, y and x axis, you try to just write down the relation into that. Why? That, like in this case, log of concentration and time. Okay, and concentration and time relation we have already. And what is that? Kt is equals to 2.30. Since log we have, so I just convert this ln into log a naught by 80. Is it right? Further, what we can write, Kt, because log a naught is constant only, initial concentration, no? So if I write down like this, Kt by 2.303 log of a naught minus log of 80. Can I write this? Log of concentration means what? Concentration at any point of time. That is log 80. So I'll take this log 80 this side, and we get what? Log of 80 is equals to minus k divided by 2.303 t plus log of a naught. Can you tell me now what graph we have to draw? We have two axes, y and x. Correct. What is y we have in this? Log a. So this is nothing but y. Correct. M x plus c.
Yeah, so it's a decreasing graph starting at some k naught value.
Yeah. So this will be like this. Correct. What is the slope of this line?
Minus k by 2.3.
So minus k by 2.303. We can find out this 2 point also by putting log a0 and t0. Correct. What is this? What is this distance? Y-intercept. Log a naught. So sometimes if they give you this graph, okay, this intercept or this distance gives you log a naught. So from here you can find out the initial concentration. And slope of this gives you k. Very important graph it is. Correct. Now concentration and reactant. We know the relation of this. At is equals to what? A naught e to the power minus kt. This is simply some initial concentration A naught and decreasing graph we have, which won't touch the x-axis. Exponential graph. Okay. What is the graph of rate and time? Rate and time. Okay, first, correct. Exponential graph. What is the slope?
Yeah, so it will be like the reverse of the concentration or time.
Reverse.
Yes,
Why
because
it is
at
reverse?
the end the rate will almost be constant at the end,
Hmm.
and as the reaction proceeds,
Ah.
the rate will even
So down here it will be like this, right? Parallel to the x-axis almost. Okay, but why it is like this? That's the question. Okay, I'll come back to this in the last. First, you tell me this rate and concentration. Rate and concentration. It is easy. Why you are doing this? R is equals to minus dA by dt. This is nothing but rate. What I told you. Just draw the relation between rate and concentration. So this is rate, and that is equals to what? K concentration of A. That is it. Yes, this is rate, this is concentration. So it will be a straight line passing through origin with slope is what? The rate constant. Right. Now coming back to this graph. Okay, so let me like draw some conclusion into this. Can I write down this that ln of at is equals to ln of a naught minus kt? Can I do this from this relation? Both side I have taken ln. Okay. Now we have to find out rate. So rate is what? Minus dat by dt. Correct. So I'll just differentiate both side. Okay. So ln of at by at is what? 1 by at into d concentration of a at any time t divided by dt. Okay. So this at and this side what we have, I'll just make some change into this. This will be 0, right? Constant minus k. Am I right? So now this I won't write this dat over here because this at is what? Because it is not like good to write like this.
Not equal.
At is nothing but the concentration of A at any time, right? This is nothing but at. So I'll write this term over here, which is nothing but rate, if you remember. Correct? So what I'll write here, I'll just erase this. So I'll write here this. Okay. Concentration of A we have here. Right, minus KT. Now, if I write down D concentration of A by dt is equals to what? Minus K into AT, right? And AT is nothing but A naught e to the power minus KT, correct? So I'll write down A naught e to the power minus KT. That's why it is exponential graph. And rate is minus dA by dt. So I'll put minus sign here. And minus minus becomes what? Plus. So the graph will be obviously, if you do not know this thing also, then we know the rate and time graph is with time the rate is decreasing, right? Theory. Concentration is decreasing, so rate will also decrease. And rate and concentration, you see, rate and concentration are what? Directly proportional, right? So concentration and rate are directly proportional. So whatever the graph of concentration and time we have, that will also be the graph of rate and time. Is it clear? So with this also, these two graph, we can get this. How it is exponential, you can explain by this particular relation. Is it clear?
yes.
So all these graph you must remember. The last thing that we calculate, and this is not important, but they have asked once in 1999 JEE exam. Okay, so we'll just see the like calculation here. You see, if I have to find out degree of dissociation, can you find out this? Which is nothing but alpha. Alpha is equals to what? Concentration reacted by total concentration. So what is the concentration reacted in this? That is X by A naught we have to find out. Okay, and you see at time t, what is the concentration left? At is equals to a naught e to the power minus kt formula. So what is the concentration that reacts? It is initially it is a naught minus at which is left. This is it. This is what reacts. This is the concentration which reacts. No, it is the initial value and it is the final one after time t. So when I take this a naught common, it becomes what? 1 minus e to the power minus kt, which is nothing but x. Correct? This x you substitute here. We'll get what? 1 minus e to the power minus kt. Right? So alpha is equals to 1 minus e to the power minus k into t. Okay. So 99, J99, they have asked this question once. Okay. So you never know what they are going to do next. You must remember this relation. Okay. Okay. Now you get your centum module. Okay. We'll see some questions onto that. All of you have Ramcharan Kondanya. You have centum module now.
So
Okay. So you open up the exercise. Okay. Question number. Question number 2, 4. Exercise 2. Exercise 2. Question number 2, 4, 12, 7, 15. You solve this much, then we'll see. Let me know once you are done. Hello. Hello. हाँ. Done. Okay. Ramcharan, finished?
The last.
Okay. Kondanya? Aditya?
Yes, sir, done.
Okay. If you have solved, or do you need me to solve this? Like, do you want me to solve this?
The second one.
It's question number 2. Okay. Question number 2. You see, the question is what? It says 2a. Just a second. Let me take this. 2a plus b gives a to b, right? And the concentration, say in this, there is one thing that is not given, that, and you have to assume that the reaction is what? Reaction is a simple reaction or elementary reaction. I think after that you can do this. If it is a simple reaction, then we can write R is equals to K, concentration of A to B1, correct? The stoichiometric coefficient is nothing but the power will be over here. Okay, now when the concentration changes, the rate of the reaction changes. So R dash will be K will not change. A is doubled and B is half, right? So R dash is equals to A becomes what? 2 concentration of A square and concentration of B by 2 to the power 1. So this becomes what? This 2 and this 2 will get cancelled. So we have 4. So we are left with 2K concentration of A square and B, which is nothing but 2R. Right? So rate becomes twice, double of that. Any other question?
12th
Question number 12.
calculate.
The rate constant of first order reaction is this. How much time it will be reduced? Okay, fine. You see, the first thing in this, that one additional information I'm giving you, the rate constant of a first order reaction, it is mentioned. Okay, if this first order is not mentioned, then what you will do in this? So first we solve this question, then we'll come to this question again. Okay. Okay. So what is given? K value is given. Okay. K is 6.9 into 10 to the power minus 3 second inverse. How much time it will take to reduce the initial concentration to its 1 by 8th value? So A naught is the initial concentration. So 80 is what? A naught by 8. Okay. So after, see, A naught to A naught by 2, and then A naught by 4, and then A naught by 8. This is what the time required, no? So what is this time? So you required 3 half-life basically. And half-life is what for first order reactions? It is given. And you see how they have given the K value.
Yes.
So it is 693 into 10 to the power minus 3 divided by 6 9 into 10 to the power minus 3 into 10 in the numerator. Everything will get cancelled. You will get 10 only.
Get
Yeah.
They're getting 100.
6 point. Yeah.
What is it's given?
0 point. You get 0.3 by 6 point.
So it's correct, no? 0.693, 0.6 minus 3, 6.9, 10 to the minus 3. This is what the answer we have. What happened? Oh, they have taken. What is the answer? 100 seconds, no?
No, no, the answer will be 3 times that because
So T half is 100 seconds, no? But we are not getting 100 seconds. We are getting so it should be 6.93 then. It should be. Otherwise the answer will be 10. So no, correct. So T half is this. So answer will be 3 times of this. Right? 300. Understood? So you see the value of K, you see 6.9. So if this kind of value is there or any multiple of 0.693 or close to this value if you have, then you must have the idea of using this T half. But with practice, you'll come to this. You'll come to know all these things. Then what you have to do when you can do this also with like T K is equals to 1 by T ln of A naught by AT. But there we have calculation. Yes, Ramcharan?
Yes, I tried doing it.
One thing also you can understand here that after n see 1 2 3 after 3 half life the A naught is this. So if you have this A naught, so after n half life the concentration is what 1 by 2 to the power n A naught. Can I write down this? Where this n is not the order, it is the n is the number of half life you write down. Don't get confused with all this. Number of half life. Yes. Now coming back to one more thing here. In this question it is given that it is of first order reaction. If suppose if this first order is not given, then what you will do? Everything is given, first order is not written. Then
but how can it be?
that's what I told you. This thing.
I mean, not even if that's not that we don't have a nation for half time.
No, that's what I told you. Sometimes order won't give, but they'll give you K, unit of K. So what is the unit of K you see? What is the unit of K? Second inverse. It means it is the first order reaction. Understood, Aditya? Okay, so this you must keep in mind. Okay, this is very important. Okay, unit of K is very important. If K value is given, it means you have the order of the reaction. You know the order of the reaction. Only you need to find out from that formula. Okay, question number 13 you solve next. Question number 13. Question number 11 you also tell me. Question number 12, sorry, 13, 11 and 8. I'll just come. Okay, you solve this. 2 minutes.
only question 11 and 13.
Question number 8, 11, and 13. 8 also. Kondanya? Okay. What happened?
We
Done?
Yes, sir.
Okay. So you tell me, how have you done question number 13? Amog, you tell me question number 13, how have you done?
so I just use that formula. First for
Formula, right? 8, that K is equals to 1 by T, ln A naught by T.
So I took like half life,
How?
basically 75%. It'll be two half lives.
Correct, correct. That is what you need to do, Amog. You can solve by equation. There is nothing into that. Okay. But then again, it requires calculation. Okay. But if you solve like this, suppose reactant we have here, and since it is a question of percentage, so whenever you have percentage question, no, it is always best to use 100 initially. Whatever it is given in the question, that is let it be assume 100. Okay. And suppose this is the 75% completion we have, right? So what is left here? 25. So you tell me the question say the reaction proceeds from here to here, and what is the time required for this? T is equals to 32 minute, right? Minute only, no? 32 minute. Okay. So can you tell me what is the time required for this 50% of completion? It is T half from here to here,
then
and then from here, this also requires one complete one half life here, T half, right? 50 to 75 again requires what? T half life, because this is, if you start reaction from here, then this is the initial concentration and this is the final one. This is exactly half of it, 50 to this. So basically in the question it is given 2 T half is equals to what? 32. So T half is what? 16. Yes. For JE question you have to solve like this, okay? But if you solve like this in board exam, you won't get marks. Okay. So in board exam, you try to solve with the formula. Okay. And then you do that. If you don't have time, you can do like this, but avoid using all these uh, tricks in board exam. Okay. That would be better. Okay. Question number 13. Understood, all of you? Question number 11. I think it is easy, right? Question number 11. How did you do this? Half life is 15 minutes, and from 1 to 0.025 it requires what? 2 half life. Yeah. Okay. Question number 8. You tell me. How did you do question number 8?
0.8.
Ramcharan, tell me.
That one I use the because you'll get like log 4 and
So you can do without.
How?
Yeah, the same person. Yeah.
The 0.8 to produce 0.6 means 0.2 moles of waste used.
Huh.
So that 25%.
Correct. Exactly. So if you,
0.8
huh,
0.6 again is 75.
correct. So you can do with the formula also. A naught is given 0.8 mole, right? 0.8, whatever it is, mole concentration, that's not a concern. AT is what? 0.6. Okay. So with the formula you can do this question. Okay. Uh, but sometimes what happens when you use formula, K is equals to 1 by T ln A naught by AT. So this ln term will not easy to solve over here because the ln value is not given. You'll get some complex expression over here. That becomes difficult. Okay. So you should know all those method which is required. Okay. But in board exam, you will not get complex term over here expression. Okay. You can solve it easily. But here what happens? The change, we know in first order, equal percentage react in equal time. Right? This we have discussed. And for this, the time required is what? T is equals to 1 hour. Right? Now, what is the percentage that reacts? That we have to find out first. So, what is this? It is 0.8 to 0.6. So, zero point 0.2 into 100 by what? 0.8. So, what is this? 25%. Okay. Means for 25% of the reaction to complete, the time is always, what is the time required? 1 hour. Correct. And luckily, if you see, it is given 0.9 to 0.675. So when this, if you solve by this formula, I think there will be some calculation in this. Okay. But you see here, zero point 0.9, if you calculate 25% of 0.9, what you will get? That will be 0.9 by 0.9 by 4. And this value is what? 0.225. And now you see, this is the 0.25% of this 0.9. Means if this reacts, what is left? 0.9 minus 0.225, which gives you what? 0.675, which is given in the question. So luckily you are getting exactly 25% of reaction here also. Okay, and that's why we have already discussed that in first order reaction, equal percentage reacts in equal time. So this 25% requires 1 hour. This 25% also requires what? Answer is this. Understood this? Then you have to use by this formula. Then you don't have any other option. Okay, then you have to use by this formula. But suppose if you stuck somewhere here, okay, and ln value is not given, then you try to use some all these kind of trick. Okay, maybe with the use of these tricks you can solve the question easily. Okay, so you have to keep this in mind. Correct. Now you see one question, we'll see question number 3, database question. You see question number 3. This question I'll discuss now. Okay, and then you do other question which is given in the module. Okay, so we are discussing now question number 3, data based question. These questions you can do by looking at the data itself. Okay, so you see there are 4 experiments. Okay, there are 4 experiments. I'll write down the thing first. A, B, it is the initial concentration of A, then we have B, and then we have rate. Okay, and the reaction it is given, and the reaction is A plus B gives product. Question number 3 we are discussing. Okay, so this one question I'll discuss. We can do the other question which is given in the next page, same type. 4 experiment we have, 1, 2, 3 and 4. What is the initial concentration of A? It is 0.012, then 0.024, 0.024 and 0.012. This is A. 0.035, 0.070, then 0.035, and then 0.070. The rate is given 0.1, 0.8, 0.1, 0.8, 0.1, 0.8, 0.1, and zero point 0.8. Okay, you have to find out the rate expression. Okay, so you see, for JE, okay, you don't have to do the method, but method I'll tell you for board exam, because the pattern, that the method that we are using to solve this question in JE, that we cannot use in board exam. You won't get marks. You'll get 3 or 5 marks question on this. Okay, they ask question on this in the board exam also. You see, first, any one set of data you have to take as a reference. Okay, any one set of data. Okay, suppose I have taken this as the reference. Okay, the first one. Okay, you have to assume that one data is correct. Okay, suppose this one is the correct data we have. Now you see what we are doing. We have done this experiment once. We have taken some concentration of A and B, and we got the rate is this. Again, what we have done in the next set of data, we have increases the concentration of A by twice, and this also by twice, and the rate is this. We cannot decide from here. Okay, but if you can take these two data, if you see, the concentration of A is what? Concentration of A is same, concentration of B is half, right? If you say first and fourth data, concentration of A is same and B is what? Twice. So if you see concentration of A is same and B is twice, then the rate, do we have any change in the rate? Yes, we have 0.1 to 0.8. It means what? The rate of the reaction depends on concentration of B. Is it clear? Clear? If you see concentration of A in second data, it is 0.24, and in the fourth one we are comparing, the concentration of A is changing but B is constant only. Rate is what? Constant or changing? Rate is constant only. It means the rate of reaction does not depend on the concentration of A. Ramcharan and Kondanya, is it clear?
Yes, sir.
Concentration of A we are changing, but there is nothing like that. Like the rate is constant only. Rate is not changing. It means rate is independent of concentration of A, but rate depends on the concentration of B. Okay, how it? So one thing is what that we come to know, that rate we can write A K, concentration of A to the power 0 and concentration of B to the power, suppose any number x. This x only we have to find out. Now you look at the option. Okay, obviously C and D are not possible. A and B are left. Okay, so now you see, if you have first two data, if you compare, A you let it be now because it has nothing to do with the rate of the reaction. Only you see B. B is double. The rate of the reaction is 8 times. When it is possible? When this x value is what? 3. Is it clear? Kondanya? Clear, no? Now this, like this you can compare and you can write down the answer in like 10-15 seconds, okay, for JE. But if you have to do this for like you say for board exam, right, then we cannot take like this. Okay, you cannot say like this compare, because you are not writing down anything, right? So how the examiner or the person who is correcting the paper, how they'll give you the marks? Okay, that's the thing. The point is, the method that we use to solve this kind of question for board purpose is this. What we do, we just assume the rate of the reaction first. Okay, and what we write, you see, suppose the rate law of this reaction is suppose this. I'll write the general rate law, a to the power x and b to the power y. Correct? I can assume this. Okay. Now, on the basis of given set of data, we'll try to frame the equation. Rate is what? 0.1 first set of data. K you let it be. And A value is what? A value is 0.012 to the power x. B value is what? 0.035 to the power y. This is equation 1. Correct? Second set of data is what? Rate is 0.8. K, you let it be as it is. 0.024 is A to the power x. 0.070 to the power y. This is 2. Now again the third one, the rate is zero point 0.1. K, you let it be. A is 0.024 to the power x. 0.035 to the power y, and the last equation, it is 1. Okay, 0.1. 0.8 is equals to k. 0.012 to the power x. 0.070 to the power y, and this is equation 4. Right, now we have to solve this. So what we do, we just divide the equation. Okay, you see, if you divide first and third, what happens then? This y and y terms will get cancelled. First and third, right? So this y and y, this by this is sorry, left hand side we have 1 only. 1 by 3 we are doing. What is the left hand side? 1 only. 0.1 and 0.1 get cancelled. We are left with 1 is equals to 0.012 and 0.024 is what? 1 by 2 to the power x, and this y term gets cancelled. If you solve this, what you will get? X value is what? 0 only. Right? Now we have to cancel out the x term, right? So first and fourth. First by fourth. 1 by 8 left hand side, and right hand side what we'll have? This x will get cancelled and we'll get 1 by 2 to the power y. So y value is what? That is why the rate expression is what? R is equals to k, concentration of A to the power 0 and concentration of B to the power 3. This is what the method we have for board exam. Okay, if you have to solve this question in board exam. Okay, this we also call it as initial rate law method. Okay, to find out the rate expression or rate, it is initial rate law method. Okay, now on the basis of this, you can do the other question which is given. Question number 47, you see.
So can have like a 5 to 10 break.
Okay, it's already 6. Now we have classes till 6:30. Okay, fine, you take break. Okay. After the break, we'll see question number 47 for 51. Okay, 47, 51, and 61. Okay, one change you do in this 47. The third experiment we have, no, it is 28.8, not 2.88. Correct? The initial rate is 28.8. Fourth experiment, it is 24.0. Correct? Okay. After the break, we have it's like it's 6 o'clock. We'll start at 6:15. Okay, and then we'll solve this question. Okay. Okay.
So can you start?
Hello.
No, yes, sir.
Yeah. Hello.
Yes, sir. We can.
Huh. So you solve those questions?
Yes.
Hmm.
What is the 61?
47 and 61. 51, there is some calculation into that. You can do it. This is your homework. Okay. 51, you don't do now. Okay. 47, 61. The pattern is same.
47 is
47, you have done. 61. Okay. What about others?
I'm doing 51.
Okay, fine.
51, Mr.
51
Yeah,
is 51 you let it be. 61 you do. But 51 you do it at home. Okay, it's your homework. Little bit of calculation is there. Kondanya, Ramcharan.
So I finished 61. I'm doing 47.
Okay. All these are initial concentration.
Yes, sir.
This is the next one. It is not in the booklet. I am giving you this. 2 into 10 minus 2, 4 into 10 minus 2, 8 into 10 to the power minus 2. B is 3 into 10 to the power minus 3, 3 into 10 to the power minus 3, and it is 9 into 10 to the power minus 3. Rate is 5 into 10 to the power minus 6, and this is 10 to the power minus 5, 1.8 into 10 to the power minus 4. This one you solve. You have to find out, first question, order with respect to A and B. Second one, overall order. Third one, rate law expression, RLE. Fourth one, effect on rate if volume gets double. Do this one.
Yes, so the orders of A and B are
I didn't get you, Aditya.
the orders of A and B.
Hmm.
There are one and two,
Hmm.
and the overall order is
Amog. Okay, let them do.
So A order of A is 1,
Hmm.
B is 2, and overall will be 3.
RLE.
Sir,
Hmm.
is it 5 into 10 power minus 6? The first one. The first
Ha ha ha. Yes, yes, yes. Huh.
yes, sir. The order with respect to A is 1, with respect to B is 2, and overall order is 3. RL is A B square.
Effect on rate. That you can do again. Okay, how did you get this A1 and B2? Kondanya, have you finished? Kondanya?
Yes.
Okay, how did you get this A1, B2? So you have used the expression a to the power x, b to the power y, and then okay. See, one suggestion I'll give you, and that is what whenever you have this kind of expression is given, no, a into 10 to the power minus b kind of expression, okay, then what you do, you try to write down 10 to the power whatever number we have here, same everywhere. Okay, like suppose it is 10 to the minus 6. Can we write this 10 to the minus 5 as 10 into 10 to the power minus 6?
Yes, sir.
And this we can write what? 100 and by 100, right? So 100, if you do 180 into 10 to the power minus 6, can I write down this? Now you see, now you forget this term and this term. Now advantage of this is what you can clearly see the rate becomes double over here, and here it becomes what? 36 time. Here you see first and third, if you compare, the rate is 36 time. First and second, the rate becomes double. Now coming back to this, like we know the board method is what? A to the power x, b to the power y. Substitute this rate and this, and you can solve by dividing those equations, correct? Okay. Now when a become thrice and b become twice, then rate is this. Okay. So when sorry, when a becomes thrice, it means rate also becomes right. But this gives you what? The rate becomes totally 36 time, right? So 3 into 36. So 12 we can put, no? So for 12 it will be so 2
The 4 into 9.
4 into 9. Yeah, 4 into 9 we can say 4 into 9. Okay, so rate becomes just a second.
A is
We can come.
A
Tell
is
me.
F4 and B is so
Oh, A is fine. A is 4 times. No, I thrice I told. My mistake. So now you see 1 and third. A becomes 4 times, means rate is 4 into A, and here we should have 9, right? For 9 it would be, we should have 3 square over there, because why 3? Because B is getting thrice, right? So means what? If you can write like this, A is direct, rate is directly proportional to A and B to the power 2. See, this is just, we are looking at the data and when giving this expression. Okay, so it's just the calculation we can do, like according to your comfortability, right? So when you see here, when A becomes 4 times, we'll have 4A here, correct? Now we are cross checking this. We'll have 4A here, and B becomes thrice. B becomes what? Square of it. right? Square of it. So we'll write what? 3b square. So this becomes what? 9 into 4, 36 ab square, and that is what we have here, 36 time of this. So the purpose I have given you this question is to make this like 10 to the power thing same everywhere. Your calculation will be easy then you can easily compare this thing by looking at the anything, but otherwise you have to frame the equation and then divide and all. Okay, so with respect to a and b, it is 1 and 2, correct? You all have done this. Overall order is 3. Rate law expression is this. Now see, we can write down this rate law expression. R is equals to k a and b square. So if the option is given in terms of k, it is fine. Otherwise, with all these data, you can find out k also. No? This rate you substitute, a you substitute, b you substitute, you find out k. So sometimes they'll put the value of k also over here. So in that case, what you have to done, once you know the rate law expression, okay, pick any of these three data, put over here R, A, and B, calculate A. With all the data, you'll get same value of K. K will not change. Is it clear? Now, what happens if the volume gets double? Tell me.
So then concentration
Becomes half.
by
It will become 1 by 8.
Yeah, right. When volume gets double, concentration becomes half, right? So new rate expression we can write, and that will be R dash is equals to K concentration of A by 2 and concentration of B square by 4. So this is nothing but R. So the new rate becomes is the 1 by 8th of the initial one. This is what we have. Okay. These are few important examples we have done. Okay, so you can solve all the question which are related to first order and zero order. Okay, all the question you must solve. You must do practice in this chapter. Otherwise, you will feel like, okay, I know everything. I can do. There are small reactions. Sorry, relations are there. We can do. But when you solve, you'll get all those tricks. You'll come to know that what you can apply to solve a question. Okay, you will not get very lengthy calculation in these kind of chapters. But these kind of chapters, one more thing, it is very important. You are the students who are going to compete the exam, they are not going to lose marks in this chapter because it is completely mathematics. Okay, complete calculation and all. But in chemistry, see, chemistry is an informative subject. Okay, if you do not have one particular information, you cannot do one question. But in this chapter, there is no information required. Everything is mathematics. So you cannot lose marks over here. Everyone who are going to complete the exam, they must score in this chapter. They don't lose marks over here. So you must do practice. Okay, one small thing we'll discuss. Okay, we don't have time that much. Okay, actually we do not have time. It's already 6:30. Okay, I'll give you some question in this. Okay, you see, for practice we'll see next pressure, and because it takes some time, the next thing that we are going to discuss. Okay, see, question now in miscellaneous solved examples, you also see question number first you solve. Okay, miscellaneous page number 1101. Question number 1, question number 3. See, question number 2, you see the expression. This pressure term is given, no, P naught by P.
So which way?
1101. P naught by P. Question number 2, all of you see. So P naught, they have written in presence of like instead of A, right? A is what? A is concentration, initial concentration. And we know P is equals to CRT, concentration and pressure are directly proportional, correct? So instead of A naught, we can write P naught, A minus X, we can write P, means pressure at any point of time T. Okay, so you can solve 2 also for this, but we'll discuss this pressure concept again because this is very important. You will get question on pressure only. Okay, so you may have doubt in this pressure related question, but you can solve this. We'll discuss this pressure concept next class. Okay, so first, second, fourth also you can solve. Arrhenius equation, you let it be. We'll discuss this. first, second, fourth. Okay, fourth, and then this ninth one, ninth, and 12th. Okay, this question you solve. And exercise 2 you solve all questions which are related to zero order and first order. All the questions you solve. Okay, questions related to activation energy, second order. Okay, can you do one more thing? Can you derive the relation of concentration and time for second order reaction? See, what we can write, rate is equals to minus dA by dt is equals to K concentration of A square, because it is second order. See, wait, I'll just write down. I'll do this, but I just want you to do some practice on this.
A times concentration of A square. Yeah.
See, for second order, what we can write? Suppose the reaction is A gives any product B. So rate of the reaction is what? D concentration of A by dt is equals to K concentration of A square, right?
Yeah.
Then we can do the integration and we can find out the expression. Okay, so this one you do. I'll discuss this in the next chapter again. This one derivation you do, small derivation we have, and all the questions related to zero order and first order you solve. Past year archives that you have, page number 1117. Page number 1117. You solve question number this one. Question number 1. Question number 1. Question number 2. 5. 7. Then next thing, JEE Advanced, multiple choice. Question number 3, 4. Decomposition of N2O5, the first order reaction, you must remember. And 7, question number 7. Okay, all these questions you do. Okay, next class we'll proceed from here. Okay. Okay, chalo, thank you.
Thank you, sir.
Thank you.
So,
Huh.
in a first order equation,
Hmm.
like if you have two different reactants, like,
Hmm.
will that change anything?
Things will change. See, you are this will be very complex. If you write down this A plus B and both are half, so rate what will write? Dx by dt is equals to K concentration of A 1 by 2 concentration of B 1 by 2. There are many cases possible. If the initial concentration of these two are same, if the initial concentration of these two are different, okay, then we can write what? A naught, suppose we have A naught minus X after some time, and this becomes what? B naught minus X. Okay, and then this you have to substitute here, this you have to substitute here, and then you have to solve the integration. This kind of thing you give me like one more class. This we are going to discuss in second order reaction. Next class we'll discuss what will have when two reactant are there, both having first order, when initial concentration are same and when initial concentration are different. This will discuss next class. But like you are asking first order, you are not going to have this kind of question in this JEE, because they may frame, but they will not frame, because it is very complex to solve this. It is to the power half. No, it is easy to solve this integration if you are done this integration thing properly. A naught minus X and B naught minus X, this you can solve. But when I'll give you the power over here 1 by 2 and 1 by 2, it is very difficult to solve this integration. So you will not get this question, means first order reaction with two reactant, you will not get this question. Understood? It is not mathematics. No, we are doing chemistry. Okay, understood?
Yes, sir.
Hello? Yeah. See, we can have many possibilities, but at this stage, whatever we can do, or what is the syllabus we have, according to that we have to go. If suppose the second order reaction we have, it is also possible. No, we have three reactant. One with respect with sorry, with respect to one, the order is -1. Here the order is +1 and here the order is +2. This is also possible. Correct. But when you are increasing the number of reactant, the complexity of the question increases. Now in this you see how many possibilities we have. One possibility, when the initial concentration of other reactant are same. Another possibility is what? Initial concentration of one reactant is same, different, other two are same. Another possibility is initial concentration of two reactant are same, one is different. Like this we can frame many possibilities, right? So the point is, you are not going to have any first order reaction in which two reactant are. If it is present also, then order with respect to one reactant must be 0, so that you can write down the rate expression like this: d concentration A by dt is equals to k concentration of A only, because with respect to B it is 0. Is it clear? So practically it is possible, but for JE you will not get those kind of questions, so don't worry with that. Okay, understood, Ramcharan?
Yes.
Okay, so we'll discuss from here, we'll continue from here next class. Okay, so thank you, solve those questions, okay, that I've given you. Practice is very important in this chapter, so don't like sit back, relax. Okay, solve those questions, must. Okay, okay, thank you, chalo, bye.
Thank you.
Thank you, bye.